Could humanity survive a million years in space, not visit, not explore, survive? Because one day, we may not have a choice. Earth feels permanent. It isn't. Asteroids, climate shifts, supervolcanoes, technological collapse, and billions of years from now, the sun itself will expand and erase this planet. If we want true long-term survival, we have to leave. And that's where things get uncomfortable, because space is not empty, it's hostile, it's lethal. And if you're into realistic, engineering-based breakdowns of humanity's future beyond Earth, not sci-fi hype, subscribe now. This channel explores how we actually survive out there. Now let's talk about why survival is harder than most people think. First, radiation. Outside Earth's magnetic field, cosmic rays constantly strike living tissue. Over time, that damage compounds. Cancer risk rises, DNA mutates, neurological effects increase. A short mission can tolerate it, 1,000-year civilization cannot. So what's the answer? Massive shielding, water barriers, mining asteroid rock for protection, or even bioengineering humans to tolerate higher radiation. Next problem, gravity. In zero gravity, bones weaken, muscles shrink. Hearts change shape. The body adapts in ways that are not ideal. For months, we can recover. For generations, we don't know, which is why long-term survival likely demands artificial gravity, rotating habitats. Giant wheel-like structures spinning slowly, creating a force that mimics Earth. A starship wouldn't feel like a ship, it would feel like a city. But even that's not enough, because in deep space there are no supply chains. No deliveries, no resupply missions, everything must be recycled. Air, water, waste, nutrients, a closed-loop ecosystem must run indefinitely. Crops must grow in controlled systems. Microbes must balance oxygen and carbon dioxide. A failure in that system isn't inconvenient, it's fatal. Then comes power. Solar weakens the farther you travel. Fission works for decades, maybe centuries, but a million years, you'd need fusion. Possibly antimatter, systems that can operate for millennia, and machines capable of repairing themselves. Self-healing materials, autonomous maintenance, AI controlling infrastructure and preserving knowledge across generations. Because when you're light years from Earth, there is no backup. But here's the part people underestimate. The real challenge isn't physics, it's people. Imagine being born on a starship. You never see Earth, never feel open air. Your entire world is metal walls and distant stars beyond thick shielding. How does society work? Who governs? How do you prevent conflict in a closed world with no escape? How do you preserve knowledge for centuries without cultural decay? Over generations, humanity might change. Different values, different biology, different identity. After thousands of years, are they still Earth humans? Or something new? Maybe survival doesn't mean preserving humanity exactly as we are. Maybe it means allowing evolution to continue in space. And perhaps the future isn't one giant arc drifting alone. Maybe it's a network. Multiple habitats, independent civilizations spreading slowly across the galaxy. Each one adapting, each one carrying fragments of Earth's memory. Survival at that scale demands more than technology. It demands purpose. Why go? Because extinction is permanent. Because curiosity is powerful. Because survival is instinct. The universe is vast, indifferent, brutal. But if we engineer resilience, biological, technological, societal, then survival stops being fantasy. It becomes design. And maybe descendants of Earth won't see this era as primitive. They'll see it as the moment we decided not just to explore the cosmos, but to endure it. Like the video and subscribe. It isn't science fiction anymore. It's engineering.